Hi everyone. I am Anuj Kumar, Prime Minister Research Fellow, IIT Roorkee, and the TA of this NPTEL course, Colloids and Surfaces. And this is the assignment 7 of the course. And okay, so this is, let me just check whether, okay, all right. So, the first problem of this particular session is an approximate expression for the repulsive potential energy due to electrical double layer overlap is given here. Okay, versus the surface to surface separation distance. S is the separation distance between two spherical particles of diameter d. Sorry, in the formula it is d. Okay, with the same surface charge is given by. Okay, so these are the standard values you are given. The permittivity of the space, and this is the relative permittivity of water, and psi naught is the surface potential, this surface potential, and k is the inverse Debye screening length. Okay, or you can say 1 upon k inverse, or that's why it is called the, this is Debye screening length, that's why it is called inverse Debye screening length. So what is given also, the particles have a surface potential of 25 millivolt and are immersed in water containing 1 millimolar NaCl solution. Okay, so assume that the presence of salt does not affect the dielectric constant of the medium. The diameter of the spherical particles is given here. Okay, is 1000 nanometers. So let me write all the given things here. This one. So okay, I will do whenever it is required. Okay, so what you have to calculate, the first is the inverse Debye screening length, or you have to calculate the kappa value. Okay, and you report your answers in SI units. So let me solve this particular question. Okay, you know, k is e square by epsilon kbt, and this okay, this is the standard formula, or you can say k is equal to under root multiply by epsilon r epsilon naught kbt. Okay, and these are the standard values you are given: 1.6 10 raised to minus 19 square, you know, this term, and this is, I am putting it as such. Okay, relative permittivity you are given 74.5, and for the space it is given 8.85 10 raised to minus 12, and the value of Boltzmann constant is this, and you can write it 298 because 25 degrees Celsius is the temperature. Okay, so all the terms are given here except this term you have to calculate. For that you have to just see the concentration of electrolyte, this one, that is the 1 millimolar NaCl, and it is dispersed in the water. So usually what will happen, it will dissociate in this term, and 1 millimolar you are given here, yes, 1 millimolar. At the result, 1 millimolar sodium ions will be formed and 1 millimolar chloride ion will be formed. Okay, so for calculating this term for sodium ions, what you have to do is 1000 multiplied by molar concentration into Avogadro number. Okay, so 1000 convert into 10 raised to minus 3 molar. So 10 raised to minus 3 into 6.023, 10 raised to 23. Okay, this will be cancel out. Okay, so you will get the this value for Na positive. Okay, similarly you are having the same concentration for chloride ions, and uh, you will get the same value for chloride chloride ions due to it is having the same concentration as it is the for the sodium ions. Okay, so let me write here. So n sodium plus you have to write first, that is the 6.023 10 raised to 23. And what is the charge for sodium? That is 1 square, plus similarly for chloride ions you can, okay, and this will be the same. Okay, you can solve easily. It will be 38, and it will be something like that, right? And
Yes, sir.
let me just calculate. You will be getting 271,143.81, okay, into 10 raised to minus 35. Let me verify. Okay, and upper term will be 26.023. That will be 30.83 into 10 raised to minus 38 plus 835 minus 15 and plus 35. And okay, let me write here. It will be 20, and if I write like this, it will be 1 2 3 4 5. Just verify the calculations, okay, and easily you will get the value of this term kappa value, and that will be the answer here. Okay, uh, I will solve it. Yes, Gautam is there. Gautam, can you please
Yes,
check
sir.
these calculations?
Yeah, yeah, I'll do.
It will be plus 20, and after that you will get 30.83 divided by 2.711 multiply by 10 raised to 15. Okay, and after that you can write 3.083 2.71 into 10 is to 8, because that will be 16, and after that you will get the 10 is to power 8.
It's coming around 337 into 10 power minus 2.
337. Oh, okay, let me check.
Uh,
Let me check.
uh,
3.083 divided by 2.711. Okay, it will be 1.137, and by under root you will do,
that's plus 20.
it will be 1.0610 is to 8, something like that. Okay,
Yeah, yeah, yeah,
clear.
yeah, yeah. Okay.
Okay, let me go to the second one. The strength of the electrical double layer potential at 3, 6 and different separation distance you have to calculate, and for that particular problem, in this particular problem you are provided this potential term. Okay, let me write here, that is VEDL over, it is electrical double layer overlap potential, that will be uh, pi epsilon naught r d naught square, an exponential minus kappa s. Okay, so phi will be 3.14 and epsilon naught, 8.85 10 is to minus 12, and it will be 74.5. And for d, diameter is given, also given here, the diameter of the particles is 100 nanometer. Okay. So 100, 10 raised to minus 9, that will be in meters, and psi naught square, that is 25 millivolt you are given, 25 millivolt. Let me convert into volt, an exponential of minus kappa. You are having the kappa value of This 1.06 into 10 raised to 8 and multiply by 3 nanometer. That is 3 10 raised to minus 9. Simply solving it. 3.14, 25, 74.5. Okay, 2070.28, 10 raised to minus 12. It will be 10 raised to minus 7, and it will something like this. An exponential uh, minus 3.18 into 10 raised to minus 1. 070.2625, that you were getting 1239. Sorry, 193925 into 10 raised to minus 25. Okay, and the exponential of 3.18 divided by 10, that is my 0.318. If I'm writing this, it will be 1 2 6 19, an exponential. Okay, 0 minus 3.18. It will be around 1.293, 10 raised to minus 19, and 0.72. Okay, 1.293, that is 0.95040. Okay, so this will be the final value, but you have to express your answer in units of thermal energy, and you have to uh, take the value of temperature is 300 Kelvin. So let me uh, convert it. It will be 0.940 10 raised to minus 19 and divide by kBT. Okay, 0.38, 4.14. It will be minus 19 plus 21. 4.14. That is 0.227 or 22.7 terms kBT. Is it clear? Okay, similarly, you can solve for the 6 nanometer and 9 nanometer. Okay, uh, please try at 6 nanometer by yourself, please, so that uh, you will be practicing more. Okay, just put the value of 6 nanometer here, separation distance. Okay, try quickly, and I will also check the answer. I'm just trying to solve by another way. Minus K S1 plus S2. S1 is S2 is 3 and 6. Exponential K value is 1.6. Six, 10 is to 8, 9, 10 is to minus exponential will be minus 9.54 into minus 1 or 954. Okay, so VDL1 VDL2 is 22.7 kVT multiplied by point 385. 16.34. Are you getting the answer? Hello. Okay, so you can just try this quick method. Okay, what you have to do, you have to just take the, have you got the answer, Gautam? You can
No, sir, still I'm doing. Yeah.
okay. Okay, for a quick answer, what you can do is uh, let me, you have to just take the ratio. Okay, if you are getting this term, the 22.7 kbt for 3 nanometer, okay. So here is one point. You can see this term is constant for all the separation distance, okay. So if I write VEDL at 3 nanometer and VEDL at 6 nanometer, and if I take the ratio, these terms will be cancelled out, and what you will only get the exponential minus k at 3 nanometer. Let's say it is s1, or divided by exponential minus k s2, okay. And as a result you will get minus k s1 minus k s2, sorry, plus s2, and exponential will be minus k s1 minus s2. So you are already having the value of s1 and s2. You are having the value of this 3 nanometer potential, and you can get easily the potential at 6 nanometer. Clear? You don't need to go through these long calculations. Is it clear?
What is it?
Got it? Okay. So the next question, I think the time is okay. No worry. So the collider particle has a 40 millivolt surface potential in 1 1. That is the symmetric electrolyte given here, and the concentration is also provided. You have to calculate the electrical double layer thickness. I have previously solved that. You have to just deal with the K inverse. Okay, what you will do? Uh, okay, this is case in 1 upon k. You can calculate epsilon kbt and e square zi square infinity square, okay. And this will be our electrical double layer thickness, okay. But for this term,
Z1 and Z2 is 1 and 1.
what, sorry,
Z1 and Z2,
uh,
both are 1, right?
you can just type in the chat box, please. I can read it. Both Z1 and Z2 are 1. Yes, both Z1 and Z2 are 1. But except these values, you have to just put in mind the concentration of the particular electrolyte you will, particular ion you will get. Okay. So if I am saying this is 1 1 electrolyte, okay, or I can say NaCl, for example. So it will dissociate into Na plus and Cl. So what you have to do is point triple zero one. It will be formed the point triple zero one molar concentration of sodium ions, and point triple zero one molars of chloride ions. Okay, so you have to put these things in mind. You have to put the concentration of these ions, not of the electrolytes. Okay, let's say if you are having, I will discuss in the later question. Okay, so this is clear. You can calculate easily. You have all values here. Okay, is it okay with you? So I can go for the next question.
KB is constant, right?
KB. Okay, sorry for that. So you can just type in chat box, because your voice is not so much clear. Yes, KB is Boltzmann constant is constant value for every question. Okay. if a particular temperature is given in any particular question, so you have to put those value accordingly. Okay, just for example, here the particular fluid combination is maintained at 300 Kelvin temperature, so you have to calculate the kappa value at T is equal to 300 kelvins. Okay. Okay, so you have to calculate the potential at a different separation distance. What you have to do uh, in this particular question, you are given the Debye-Hugel approximation. So you can do directly this one. You can use direct formula. Okay, but you have to calculate this value, and you are already getting this value in the question. It is already given here. That is a 40 millivolt. Okay, surface potential, and the kappa value you will get from the first part, this part. Okay, and the x is the separation distance you are you have to put accordingly. That is whether it is 30 nanometer, 20 nanometer, and 10 nanometer, and 1 nanometer. Okay, so what you will get, I will share the complete solution with answer also, but here is the time limit, so I can just elaborate the things. Okay, so kappa value you will get from the first question, and the separation distance you have to put, and you have to do just simple calculations, and you will get the value in. Uh, okay, directly you have to answer in millivolt. Okay, so if you want, you don't need to change the units. That is, it is a for millivolt. You can just write it as 40 millivolt, and you can solve this part. Okay, if it is clear, you can just type yes. What will is the value of E and E in the calculation of K? uh, in the calculation of K, the E value, the epsilon value will be, okay, sorry, epsilon value will be the epsilon r and epsilon naught, and the permittivity is given to you this value, and the relative is you have to use the 74.5. Okay, so these are the standard values. Okay, you can just choose this value, because the dielectric constant of water is fixed. Okay, you can also put the 78, the standard value of this water. Okay, and the another value you are asking for, E is the, sorry, E is the, basically E is the charge on electron 1.6 10 raised to minus 19 coulomb. You can put. Okay, so Gautam, if you are clear, so I can I will move to the next question. Just type yes, because we have okay, okay. Oh, so I am going to the next problem. That is a simple problem. You have to calculate the potential energy of interaction between this. So normally apply the formula from your 12th standard. That is this one. Okay, and the permittivity of vacuum is given here. You have to put the value of this 8.84 10 raised to minus 15, and the charge will be 1.6 into 10 raised to minus, because only one charge is there, and the r is the 1 nanometer apart, so 1 into 10 raised to minus 9. Okay, and you will get simply the value in joules, but the multiple of 10 raised to minus 19. Okay, so you will get something like uh, 2 point 2.0 and 2.6 in this range. Okay, clear. Okay, This is Gautam. This is your question. You have posted in the discussion forum. Okay. So consider an aqueous solution containing asymmetric electrolyte. In the case of asymmetric electrolyte, what you have to do specifically, okay, you are given here the Z positive and Z negative ratio. It is 3:2. So first thing what you will do is you will construct the molecular formula for the neutralization of charge. Okay, let's say if I am x2y3, if I am consider it the molecular formula of that electrolyte, it will dissociate. Let's say if it is dissociating in 2x plus 3 and 3y plus 2. So total resultant charge what will be is, it is plus 3 charge, it is plus 2 charge, sorry, minus 2 charge, sorry, it will be 2 3 plus 6 and 3 2 minus 6, so it will be neutralized. So why I am writing the molecular formula, if you are having the zero point 0.1 molar concentration, so you will getting the for this positive charged ions, you will getting the 2 in multiply by zero point 0.1 molar, that is zero point 0.2 molar concentration. And similarly for the negatively charged, you will getting the zero point 0.3 molar concentration, and after that you can directly simply put out these values in for this question and this question. Okay, I think your doubt is clear now. If not, you can type in the chat box, please. Okay, just try to solve. Tell once again. Okay, let me just open the slides. Okay, what I'm saying, you are given here the Z positive, Z negative ratio 3:2. That is, it means the positively charged ion having the plus 3 charge, and the negative charge species having plus 2 charge, oh sorry, minus 2 charge. Okay, so on the basis of these charge values, you have to construct the molecular formula first, because you have to calculate the concentration of ions on the basis of that. So for asymmetric ion, let's say for example Na2SO4, okay, it is having plus 1 charge and sulfate are having minus 2 charge. So it is also example of asymmetric electrolyte, and the Z positive Z negative ratio is 1:2. Okay, so the this stoichiometry will you have to also calculate. For example, you are given Z positive and Z negative ratio 3:2. Okay, so for neutralization of charge, because the electrolyte having a zero charge in neutral conditions. Okay, so the ions which is having plus 3 charge, okay, it will be having x2 and y3, because multiply let's say forget it, if it is having plus 3 charge and it is having minus 2 charge. Okay, so calculate the overall charge, what will be it, 2 into 3, that is plus 6, and 3 into minus 2, that is minus 6, it will be neutral. So for neutralization, you have to just find the molecular formula or empirical formula, because after that you will dissociate this electrolyte in these ions, and accordingly you will get the concentration values, and you have to put the, you have to calculate the n infinity value for that particular ions. Okay, if
But
still
it's
you got it. Okay, if you got it, just type yes in the chat box. So okay, I can close the sessions of today. No way, I will share. Okay, I will share the complete solutions. Or if you have any problem, you can just post in the discussion forum, and I will discuss the same problem in the upcoming sessions. Okay, so thank you very much for attending the session. I am okay. So I am closing now the meeting. Okay, thank you. Bye bye.